everyone, and welcome back to my channel. On this video, we are going to be taking my examples on MSTs, just to drive our point home. On this example, we have to consider the graph in the question, and we want to find the cost of the minimum spanning tree, how many minimum spanning trees we have, and the third question, in what order the edges will be added if we're using the Kruskal's algorithm. So let's jump right in. So I'm going to answer to find the cost of the minimum spanning tree. That means we have to find the minimum spanning tree in the first place. And because we have a question on Kruskal's, that's the C question, I'm going to be using Kruskal's algorithm to find this minimum spanning tree. And if you can remember from our video on Kruskal's algorithm, we said we start with empty graph. We started on empty graph, so we draw an empty graph and then try to connect from the cheapest edges, the ones that don't form a cycle. So now I have an empty graph already drawn out here. So using the Kruskal's algorithm, let's try to connect these. We have an empty graph. We're going to start from the cheapest edge. We have from 1 to E, that's an edge. From E to F, we have another edge, very cheap, and it doesn't form a cycle yet. We also have we could go from B to F, that's another edge, it does not form a cycle yet. If we consider BE, which is another cheap edge, we see that it forms a circle from BE, F back to B. It forms a circle, so we don't put that down. We don't also put down A to B because it's now formed. If we have the edge A to B, it forms a cycle from A, B, F, E back to A. So we move on. So we have here 5, 5, 3. So we go with the cheapest one, that's 3. And what next? We have 4 from G to C, and any other edge within this area would form a cycle. So at this point we move on. We have from G to H, which is very cheap, 3. We have from G to D, which is the cheapest, 5. So any other edge from D to H will form a cycle. Any other edge from C to D forms a cycle. So this is a minimum spanning tree. So what is the cost? Let's answer the A question, the cost. We are going to be adding the cost of all edges. That would be 1 plus 1 plus 2 plus 3 plus 4 plus 5 plus 3. What do you have? I have 19. So the cost of the minimum spanning tree is 19. So B, how many minimum spanning trees do we have from this graph? Well, yes, it's possible to have more than one minimum spanning tree. So this already drawn here is a minimum spanning tree. If you did remember when we were drawing this graph, from B to E is the same age cost of from B to F. So while this is a minimum spanning tree we could get from that graph, we could also have done something like this. And if we instead had an edge from E to B, we see that this minimum spanning tree still has exactly the same cost. It costs 19, and it's a different graph from the first one. So yeah, we have 2 minimum spanning trees, B. We have 2 minimum spanning trees, this and the previous one, which had an edge BF instead of an edge BE. And we also have supposing we use Kruskal's algorithm just as we used to derive the first MST. In what order are the edges added to the MST? For each edge in this sequence, give a cut that justifies this addition. Okay, so let's check it out. So we could go from A to E just as we did. So from A to E, let's say we have a little cut here A to E, right? No cycle yet. Then we go from E to F. From E to F, no cycle yet. So you have this and this covered. Then from B to F, from B to F, you have this cut. Then from F to G, you have another cut this way. Then from G to C, you have another cut this way. And then from G to H, you have another cut this way. And then you have from G to D. So that's it for this first question. In our next video, we'll look at the very next question, which is also another example on MSTs. Please subscribe to my channel and like the video, share, comment, and I'll see you on the next one.